Education in data visualization is crucial for a data-literate, informed, and critical society. Our society is ever more reliant on data in all spheres of life. As evidence of that, we are seeing increasing numbers of visualizations in the news, as part of public dashboards, and in scientific reports. As educators and members of a global scientific community at the forefront of knowledge generation, we see ourselves responsible to engage in knowledge transfer, develop creative and practical approaches to education, and lead the research necessary to understand and improve education. While a lot can be learned about education from other disciplines and general educational theories, visualization as a field integrates knowledge and methods from a wide range of disciplines, such as statistics, design, art, geography, biology, psychology, cognitive science, computer science, and data science, to just name a few. Visualization is a discipline that combines complex theory and applied craft, diverse domain knowledge and applied problem-solving skills, creativity and criticality, design expertise and design thinking, all alongside a profound familiarity with data, technology, and human beings. Thus, education for visualization requires individual consideration. However, visualization is lacking a theory of education and an established body of knowledge of its own. To build such a theory, we should first ask and answer questions such as: what are the challenges in visualization education? What can we do as researchers to address these? What opportunities arise from this for the visualization community? We are 21 educators and researchers in academia who met during a one-week Dagstuhl research seminar on visualization empowerment, how to teach and learn data visualization, in the summer of 2022. During the seminar, we shared our experience in teaching data visualization, from university undergraduate levels upwards, including master, PhD, and working professionals. We work mainly in academia and currently teach in the UK, Canada, Austria, Brazil, France, Belgium, and Denmark. We identified several phases in our process of characterizing and clarifying the challenges. We shared experiences at Dagstuhl to understand the diversity of the attendees through talks, hands-on sessions, and brainstorming activities, as well as group discussions. We then collected an initial list of 60 individual challenges in education, prompted through our experience and discussions and reflections at the seminar. We then formulated, reviewed, and further refined the challenges during several follow-up meetings and identified initial themes to structure the challenges. We formed a working group for each theme and ended up with 19 practical challenges and 43 research questions. This final set of themes, challenges, and questions was reviewed and revised by all authors. Based on this, we identified 5 cross-cutting opportunities. We came up with 7 themes that organize our identified challenges. Some challenges are related to people, as people are the core of education. Some challenges are about setting learning goals and planning assessments in the context of visualization. We also identified challenges in motivating people to offer visualization courses, and challenges in methods of visualization education. Some challenges describe the environment and the conditions that learning happens in, and the materials that support education. And lastly, we discussed the challenges of adapting and overcoming inertia to change. As an example, let's take a closer look at the theme change. Developments in technology and knowledge in visualization are often sudden and variously bring in new opportunities as well as challenges. We suggest the following 2 challenges that need to be considered in this topic area. The first challenge deals with understanding the role and effects of AI. Openly accessible AI is offering exciting possibilities for visualization and analytics. The tools that are emerging are able to code, synthesize, design, analyze, and critique in increasingly sophisticated and useful ways. This is likely to have disruptive effects on visualization, how it's used, and how educators support this use that are far wider than influencing design decisions. This leads to a series of related questions, such as how do we conduct reliable assessments of learning competencies when AI can outperform students in the kinds of tasks traditionally valued in data visualization education? Or how do we revise the competencies associated with data visualization education as technology changes the discipline and its practice? A second challenge within this theme is how we can overcome inertia and adapt to change. AI is unlikely to be the only change that impacts visualization and its education. Actively identifying changes in technology and society to which educators must respond is quite a challenge, and even more so is doing so appropriately and in a timely fashion. For example, we need research to understand how do we develop and support approaches to education and educational systems that are relevant and robust in light of change. We used these challenges and research questions and identified opportunities to move forward and create better education in visualization. These opportunities include embracing diversity, equity, and accessibility in visualization education, building interdisciplinary communities for exchange and dissemination, providing actionable guidance and theory for all educators, establishing mechanisms for future thinking and ensuring that visualization education is dynamic, adaptable, and relevant in light of changes in society and technology. And acknowledge the impact of education on the future and taking responsibility to shape this future. We need to build interdisciplinary communities for exchange and dissemination. To promote diversity and inclusion and to better understand which approaches work, as well as to help disseminate practices in visualization education, we need to foster interactions between disciplines, practices, and communities. We can build communities by connecting to networks of practitioners, educators, and policymakers, and by engaging with the academic education communities. To that end, we need academic and non-academic, physical and online platforms to exchange knowledge, experience, evidence, materials, activities, and guidelines. We aim to inspire researchers and educators to drive visualization education forward and discuss why, how, who, and where we educate. We are eager to learn with and from the diverse perspectives of learners and educators in our multidisciplinary field. We hope our efforts in this paper will help foster a culture for visualization, an inclusive community, and a framework for rationalizing decisions for the many ways in which education creates interactions between the discipline, people, and the future.